Hi folks, welcome back to Physics with Captain Rod. I'm making this to be video 2 of a series on your notes on work done on a gas. So we've got an ideal gas that's running through the following cycle here. And let's see, find the work done by each part of the cycle. I went ahead and already wrote this out for you so you don't have to bother doing that. And let's see, work done by each part. So first let's talk about this part right here. Hopefully it's obvious by now there is no area under that curve, so the first work term is 0. The second part of the curve is this thing, this part of the curve. And the work done is the area under that curve, which is this trapezoidal area, or I'm sorry, I guess this kind of goofed up trapezoid here, but again, that work term, area-wise, is a trapezoid. So the trapezoidal area, remember, left plus right divide by 2 times the width. And I have written those out right here. The left-hand side of that trapezoid, I believe, is 17 times 10 to the 5th newtons per square meter high. The right is 5 newtons per square meter high. Divide by 2 times 10 to the 5th. And it times the change in volume. Now, it looks to me like we're going from 12 liters to 5 liters, so the change in volume is 0.007 cubic meters. Now, one thing on this example that I'm going to do that I did not in the previous is actually pay attention to plus and minus signs. When your sign convention is work done on the gas, that work term is positive when the gas is compressed, which would have the result of increasing the internal energy. So this work term right here, all right, the gas is expanding, which makes that work term negative. Okay, third part. So that's this part of the curve where we're going from about 12 liters down to about 5 liters. The work done is going to be equal to this area here, which is a rectangle. The height is 5 times 10 to the 5th newtons per square meter. That's this distance on the graph. The width, again, is 0.007 cubic meters. Yeah, that's right, 0.007 cubic meters. And if I calculated that out correctly, I end up with 3,500 joules, and that would be positive. Okay, the net work done on the gas, and this is referring to the work done on the gas by the cycle, ends up being minus 4,200 joules if we add these things together. Now the minus sign is kind of important to realize here. And in this context, what it means is that's a net work out of the system. So some of these problems, all right, and it depends on which way you're going on the PV diagram. Come on, I'm trying to get this to scroll back up here. Here we go. So when the PV diagrams run clockwise like this, that's just how it works. You end up with a negative number and what for the net work done. And what that means is that, how do I put this? The net work is coming out of the system. If we run it the other way, that means the net work is into the system. And the difference between them has to do with whether or not we're talking about what's called a heat engine or what's called a heat pump. I'm going to save that for another video and just end this one right here. I hope that this helps you understand PV diagrams a little bit better and how to calculate work terms. Have a nice day.